Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about causal inference. This episode is based on a tech blog titled Introduction to Causal Inference Using Double Machine Learning, written by the Microsoft Data Science team. You can find the blog link in this episode description. In this episode, we will explore the topic from both the business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Microsoft is one of the largest technology companies in the world, with a market cap of over $3 trillion and a diverse product portfolio, from Azure cloud services to productivity tools like Microsoft 365 to gaming and LinkedIn and more. With operations at this scale, the company constantly faces important questions like, did this new product feature actually improve engagement? Did our latest marketing campaign increase conversions? And what would have happened if we hadn't made a certain decision? In many companies, the gold standard for answering questions like this is A/B testing. But in practice, A/B testing ain't always possible. They can be expensive, time-consuming, or in some cases, even unethical depending on the context. In some other situations, decisions have already been made, so you are left with only observational data to analyze to start with. And that's where things get tricky. Observational data is messy. It's full of confounding variables, which are factors that influence both the treatment and the outcome. Let's add some color here. Imagine you're trying to evaluate whether getting a membership status would increase user purchases. You have data on who gets the membership status and what they bought. But the people who got the membership status might be different from those who didn't. They could be more active users or more recently signed up. So if you don't account for those differences, it's easy to confuse correlation with causation. That's where causal inference comes in. Unlike traditional machine learning, which focuses on predicting outcomes, causal inference aims to answer questions like, what causes that? It's a critical tool for product managers, marketers, and data scientists who want to know not just what happened, but why it happened, and what might happen if we try something new. Now that we understand the business context, let's take a closer look at the methodology introduced in the blog, double machine learning. Double machine learning combines the flexibility of modern machine learning with the statistical rigor of econometrics. It's especially powerful for estimating causal effects in high-dimensional settings, where many variables could act as confounders, and where randomized experiments aren't feasible. At its core, double machine learning is built on a simple but clever idea, using machine learning to control for confounders, and then isolate the portion of the treatment that is independent of those confounders. This allows for a more accurate estimation of the true causal effect. Let's walk through the process by using a simple example. Suppose you want to understand the causal effect of getting a silver membership status, which is the treatment, on the user purchases, which is the outcome. To get a trustworthy estimate, you need to conduct two steps. The first step is not unique to double machine learning. It is common to most causal inference methods. This step is to identify the confounder variables. Those are the variables that influence both the treatment and the outcome. In this tech blog, the Microsoft data science team uses causal graphs to do so. These are structured diagrams that visually represent potential cause and effect relationships, helping to clarify which variables should be controlled for. While causal graphs provide a principled and transparent approach, other approaches also work, like domain expertise can also help to guide this process. Once the confounders have been identified, now the second step is to apply the double machine learning procedure. Here is how it works. You train two machine learning models. One model predicts the treatment based on the confounders. The treatment is whether a user gets a silver membership status. Then you train another model predicts the outcome using the same confounders, where the outcome is whether the user made further purchases. This is where the double in double machine learning name comes from. There are two separate models, each focused on explaining different parts of the causal equation. These models allow us to estimate what we would expect the treatment and the outcome to be for each individual, based solely on their observed characteristics. After this comes the key part. You compute the residuals, which is the proportions of the treatment and the outcome that can't be explained by the confounders. You then regress the outcome residuals on the treatment residuals. This final step gives you an estimate of the causal effect, with much of the confounding influence removed. Besides this methodology, this blog also includes a practical walkthrough on how to implement such approach using the popular Python packages, making it easier for practitioners to apply double machine learning in real-world scenarios. It's a great blend of theory and hand-on guidance. Now we discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we looked at the role of causal inference in helping companies to make critical product and business decisions. We also explore how double machine learning uses machine learning models to control for confounding variables and isolate causal effects, offering a flexible and principled approach for decision-making when A/B test on an option. It's a powerful addition to any data scientist toolkit. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.